The purpose of this lab is to determine the specific heat of a metal cube, and then based on that specific heat capacity, identify it on that one property. The table of the information is in your book in Chapter 9 on page 314. So you're going to want to look up the actual specific heat capacities of the metals that you could have. We are going to have a metal cube, which you will not know what it is made out of, a calorimeter, which consists of 2 coffee cups and a cardboard square that covers the coffee cup, a thermometer, and then a beaker to boil water. We will start the lab by boiling water, and so we will use a Bunsen burner and then get it so that steam is rising, gas is being given off, we are at a boiling temperature. Okay? We are then going to take our metal cube and we are going to stick it in the water and let it sit for at least 6 minutes. At that point, we will assume that the temperature of the boiling water is the same temperature as the block, that all of the heat from the boiling water will have gone to, not all of the heat, but heat from the boiling water will have gone to the block, and so they have reached an equilibrium temperature, or the same temperature. We will then take exactly 100 milliliters, and it's very important that's exactly 100 milliliters, because I know that 1 gram of water is equal to 1 milliliter of water, or 1 milliliter of water, it has a mass of 1 gram. So if I have 100 milliliters, I know then that my mass of water should be 100 grams. I'm going to take that 100 milliliters and have it be cold or cool water out of the tap. I'm going to put it into my calorimeter. Okay? Oops. Then we are going to record the mass of our block, and the mass of your block is 87.50 plus or minus 0.01 grams. Okay? And like I said, we are immersing the metal cube into the boiling water, and the temperature that the two blocks reached, or the block and the water reached, was 98.1 degrees Celsius plus or minus 0.1. That it's not exactly 100 is fine. We have air within our thermometers. We have air, or not air, but different boiling temperatures at different elevations, different pressures in the air, and so 98.1 is fine. Okay, and so when we see that temperature, we are quickly going to take that block out of the boiling water and as fast as we can transfer it into our calorimeters. Our calorimeters have the cool water in there, and the cool water temperature is 22.7 plus or minus 0.1. And so that block is going to be quickly transferred so we don't lose heat to the air. We're going to lose some, but we are going to try to minimize that. And then submerge the block into the cool water and cover it with our cardboard cover. Now, we have a hot block in cool water, and so the heat will transfer hot to cold, hot to cold, hot to cold, and will continue transferring, making the temperature of the cool water increase. At some point, the cool water will reach its maximum or its highest temperature, and then it will start falling back down. When it's falling back down, that means we are losing heat to the outside. It's leaving our system. It's going into the styrofoam cups. It's going into the cardboard. It's escaping. And so we want our final temperature, our final equilibrium temperature, when all of the heat has been transferred, is the highest temperature that was reached. And the highest temperature reached after the block was put, the hot block was put into the cool water, was 33.0 degrees Celsius, plus or minus 0.1. With that information, you should be able to determine what the specific heat capacity of the block was, and then look up on page 314 what the identity of that block must be, find a percent difference, and complete the lab.